This is number 54 on page 119, and it tells us that we have two objects, one on an incline and one hanging. The one on the incline, they tell us, is 9 kilograms, so I'll just go ahead and put a 9 in there for 9 kilograms, and they tell us this one is 4 kilograms, and they're attached by a light string. This one does have friction, and I believe it's held to the floor and let go. M1 accelerates up, M2 accelerates down, and it takes 4 seconds for M2 to travel 1 meter. That's the information they give us. They also tell us that theta is 40 degrees. So this is 40 degrees right here. So the first thing, of course, we want to do is draw a force diagram, a free body diagram, each one separately. This one, of course, is going to have tension up. This one's going to have mg or f of g down, and f of g equals m times g, which in this case is 4 kilograms times 10 meters per second squared is 40 newtons. Now this one is a two-dimensional force, this mg. Of course, it's going to be 90 newtons. Then we have this normal force up this way, F sub n. There's a tension force up this way, F T. And there's a frictional force, F of F. There we go. So the first thing they want is they want us to find the acceleration. So A, they want us to find acceleration. Well, we could normally do that with Newton's second law, which is sum of the forces equals m times A. But in this case, we're not given enough information. So the information we are given is that this thing travels downhill 1 meter in 4 seconds. Well, that's the second equation on our equation sheet. X equals x naught plus v naught t plus 1/2 at squared. This whole part here is 0 because we start at 0 and start at rest. So it ends up being x 1 meter equals 1/2 a, I don't know, times 1 second squared. And so a is going to equal 0.125. If you solve this with algebra, you guys can do this. 2 times 1 divided by 1 squared. I'm sorry, this is not 1, this is 4. Sorry. 4 seconds to reach to the bottom. So if you do that, you're going to get A equal to 1.25 meters per second squared. Okay, the next part they ask us is to find the tension. Well, the simplest one to find the tension is this one right here, the hanging one, because there's only 2 forces on it. So B is going to be, we're going to use the sum of the forces equals net force, which we don't know, equals MA. So what I do with FT and 40 newtons, I subtract them because they are opposite. Down is negative, so 40 is going to be negative. So FT, number I don't know, minus 40 newtons equals, what's the mass? 4 kilograms times, what's the acceleration? 0.125 meters per second squared. All right, and so if I solve this for FT, I'm going to get F sub T, or the tension, equal to, let's see here, 40.5 newtons. So that's the answer for B. Circle my answers here. C, they ask us what the coefficient of friction is. And so to do that, we have to realize that the fun equation, so this is C, so F of friction equals mu, and this is kinetic, so these are kinetic friction, times F of N. So in other words, the coefficient of kinetic friction equals F of F kinetic over F of N. Well, that's something we didn't do up here, is we didn't figure out any of these numbers. Something that we have to realize is that the gravitational force breaks up into two parts. One part's perpendicular and one part is parallel to the incline, points down like that, parallel. This angle right here is 40 degrees. All right, so this red part here is going to be 90 times cosine of 40. When I do 90 times cosine of 40, I get 69. So 69 newtons. Well, that means that my normal force is equal to 69. And then the green part is going to be mg, which is 90, times sine of 40. And that's going to give me 58. Oops, green on that. It's going to give me 58 newtons. That means that there is 58 newtons worth of gravity pulling this object downhill. I already know tension is equal to 40.5. I don't know friction. So 58 is going to be bigger than Ft and F of F together because there's a net force downward because it accelerates downward. So if I go back down here and on 58 and 69, and let me go back up here and get black, and this equals some number I don't know yet over 69 newtons because we know that F of N 69 newtons. So how do I find F of F? Well, if I go back up and look at my picture, then I do the sum of the forces. I'm going to say friction's negative, so uphill's negative, downhill's positive. So 58 minus 40.5 minus F of F equals m(a). M is 9, A is 0.125. So if I do that, I'm going to go down here, and it's going to be, we're doing sum of the forces equals m(a). So 58 is positive newtons minus 40.5 newtons minus F of F, don't know that number, equals 9 kilograms times 0.125 meters per second squared. When I do that, I'm going to get F of F equal to 16.4 newtons. So you figure that out and do your math, and you end up getting 0.24, I believe, is the answer to that question. And that's how you do number 54, page 119. And remember, coefficient of friction does not have units.